Hello, today I'm going to talk about my favorite neurotransmitter dopamine and related disorder schizophrenia. Have you ever heard about dopamine? I think it's one of the most famous neurotransmitter. I also really like what people often say, dopamine explodes in things like watching or short videos. I will going to tell you more interesting things than short videos, so please focus on. Let's get started. So let's first focus on the dopaminergic system. We will go through 4 steps. So first, synthesize pathway. The precursor molecule for dopamine is tyrosine. And with the help of the enzyme named TH, the tyrosine hydroxylase, the tyrosine is converted to L-DOPA. And L-DOPA is converted to, finally, dopamine with the help of another enzyme, DDC, the dopa decarboxylase. And this process happens in cytosol of axon terminal. And after synthesis, there will be storage for the synaptic vesicle. The involved protein, especially transporter protein, is VMAT. It makes a synaptic vesicle by putting neurotransmitter in it, so it becomes like this. And for release, as you know, when action potential arrives, membrane potential rises, so it becomes depolarized. Then what happens? The voltage-gated calcium channel opens and the calcium ions flows in, and it activates vesicle to fuse with the membrane, postsynaptic membrane. Then neurotransmitter molecules will release into the synaptic cleft like these. Like this. Then there will be receptor on the postsynaptic membrane. For dopamine, there are 5 types of receptors, D1 to D5. So D1 and D5 receptors are excitatory. So it means they stimulate signaling of postsynaptic neuron. But for D2, D3, D4, they are inhibitory receptors, so they block signaling of postsynaptic neuron. So it stimulate, it inhibit. But it is not the end. There will be a termination after release. There are 3 types. The first one is diffusion. There can be a simple diffusion of transmitter molecules through extracellular fluid and they just away from the synapse. And the second type is reuptake process. So for dopamine, there are DAT. They are located at presynaptic terminal and they reuptake dopamine from synaptic cleft, the remaining dopamines. And the last one is the enzymatic degradation, and there are MAO and COMT enzymes. And these enzymes break down dopamine in the synaptic cleft. So this is the overall dopamine system. And let's move on to the schizophrenia. So schizophrenia is a kind of mental illness. And if I talk about the symptoms of it, there are 2 types. First one is the positive symptom. It includes like delusions, hallucinations. And the second type is negative symptoms, including like emotivation and cognitive impairments. I drew some dopamine pathways. Sorry for bad drawing. But there are 2 pathways. First one is mesolimbic, the red one. Yep. And the second one is mesocortical pathway. And there are several hypotheses that relate dopamine to schizophrenia. And what I will introduce is the recent hypothesis. In this, people say in mesolimbic area, there are hyperactive dopamine transmission. So dopamines released too much. So it is related to positive symptoms. And in mesocortical area, especially I illustrated the prefrontal cortex, there are hypoactive dopamine transmission. So it's related to negative symptoms. Then how can you treat this? The first, in the past, the first treatments are the first generation antipsychotics. Before going deep, I will explain more about D2 receptors in mesolimbic area. So as I said, there are too much dopamine transmission. So patients with schizophrenia release too much dopamine. Then they will overstimulate the D2 receptors. And as I mentioned earlier, D2 receptor is inhibitory. So there will be excessive and irregular inhibition. Then what happened? The brain information processing system will not work properly, and it will cause some symptoms like positive symptoms. So in FGAs, they usually block D2 receptors. Like it works like they work like antagonists. So I said the dopamine overstimulate D2, so we block this. That it will not overstimulate, then we can normalize the exaggerated dopamine activity. For example, there are haloperidol for FGAs, but also there are some limitations for FGAs because the blocking is widespread, so it can affect other pathways like mesocortical pathway. So if we block D2 receptor in mesocortical pathway, it can worsen negative symptoms and cognitive impairments because it is already hypoactive. So there comes second generation antipsychotics, and they also block D2 receptors, but they usually have lower affinity to D2 receptors or act as just partial antagonists, like just for mesolimbic area. So they can suppress excessive dopamine activity in mesolimbic pathway, but also minimizing unnecessary D2 blockage in other pathway. So they reduce risk than FGAs. And second work is block 5-HT2A. Do you know what is this? It is serotonin receptor and it modulates dopamine release in especially prefrontal cortex. So if we activate this receptor, then they indirectly inhibit dopamine release. So in SGAs, we block this receptor, so block inhibiting dopamine. So negative, negative, positive, negative, negative, then the result is positive. So we can promote the dopamine release in prefrontal cortex, so we can improve negative symptoms and cognitive impairments. So examples for SGAs are risperidone and olanzapine and clozapine. So as you can see, dopamine is a truly interesting neurotransmitter. This is the reason why dopamine is my favorite. Dopamine is not simply a neurotransmitter that's secreted a lot when watching short videos, but its imbalance can link to serious disease like schizophrenia, as I explained, but Also, by carefully targeting different parts of dopaminergic system, like mesolimbic, mesocortical, we can effectively treat these disorders. I hope this video has helped deepen your understanding of dopamine and schizophrenia. Thanks for watching. Bye.